Hello guys, so the question today we are going to solve is how long should water be electrolyzed by passing through 100 amperes current so that the oxygen released can completely burn 27.66 grams of diborane. Atomic weight of borane is given 10.8 units. Okay, first it is given to us that atomic weight of borane is 10.8 U, and we know that atomic weight of hydrogen is 1.008 U. So the molar mass of diborane, that is B2H6, or mass of 1 mole would be equals to 27.66 grams. Now let us write the balanced chemical equation of reaction between diborane and oxygen. So we have B2H6 plus oxygen gives B2O3 plus 3 molecules of water. Now from the balanced chemical equation, we can see that 1 mole of diborane requires 3 moles of oxygen molecule to form products of 1 mole of diborane trioxide and 3 moles of water. We know that during electrolysis of water, electricity is used to dissociate water molecules into oxygen gas and hydrogen gas. And the equation can be given as 2H2O gives 2H2 plus O2. Here hydrogen ions are reduced at the negatively charged cathode to give hydrogen gas. Similarly, oxidation takes place to the positively charged anode to give oxygen gas. So the equation can be written as 2H2O liquid gives oxygen gas plus 4 molecules of H plus ions and releases 4 electrons. Now we can see that 4 electrons are required to produce 1 mole of gas. 4 electrons are required to produce 1 mole of oxygen gas. Or we can say that 4 Faraday charge is required to produce 1 mole of oxygen gas. And we know that 1 Faraday is equals to 96,500 coulombs. Now we know that Q equals to I multiplied by T, where Q denotes the charge, I is the current, and T is the time taken. So to find out the time taken T, take I to the left hand side, so Q upon I. So we have 12 into 96,500 coulombs upon 100, that is 11580 seconds. So converting seconds into hours, we get T equals to 3.2 hours. So the correct option to this question is option B, 3.2 hours.